Okay, today is September 6th, 2019, and this is completely wrong. You're going to have a test on sections 1.1 to 1.5 on Friday.
No
Okay.
quiz? What's the day? Are you serious?
Friday, 11, 12, 13.
Wait, you're
Wow,
putting it on
Friday the
unlucky
13th.
days?
Yeah.
Everyone's gonna fail.
Okay. Oh, okay. All right. So, yeah, I don't know what I was thinking, but I realized when I finally looked at it, I was like, oh, right, it is through section 1.5. For some reason, I had it in my head that it was through section 1.4. So I was totally off, but at any rate, it's kind of nice because that puts it on a Friday. All right, 1 week from today, another big old test. And speaking of tests, your test fractions were due today. So I hope you turn those in if you wanted some bonus points back. Okay, today we are talking about the difference quotient. Working more with function notation and what function notation means. And the difference quotient is actually a calculus topic. We learn the mechanics of it in pre-calc, but this is the difference quotient, which sorry, that doesn't help you at all. The difference quotient is actually the definition of a derivative. A derivative in calculus is what calculus is all about. So this is sort of the fundamental understanding in calculus. And you'll learn what it actually means in calculus. So here we just learn the mechanics of doing the algebra to simplify it. Some of the algebra. Okay, so just so you know, today's class practice, you do need to complete it. So most students in first period got through about 105 today, and so they just have a couple to finish up for homework, but you do need to take it home and finish it today. But use your time wisely and you'll get it almost all done. We're going to even spend another day on it on Monday with the difference quotient because I want you to be really good at it. And then also, there is an extra credit posted on the class website again for this weekend too. So here we go. Example 1, find all real values of x such that f of x is equal to 0. Find all real values of x such that f of x is equal to 0. This is the function notation we want to pay attention today. This is a direction. It's telling us to do something. What is it telling us to do? Is that 0 for x? The setting, it says set the whole function equal to 0. F of x is equal to 0. F of x is equal to 0. It literally says set the whole function equal to 0. And not to be confused with find f of 0. What does f of 0 mean? That says x is equal to 0. What do you get when you plug in a 0? Okay, so very different statements. In words, we say, this is the function notation that says take the function and set it equal to 0. In words, this would be find the zeros of the function. Okay, so we have lots of different ways to say the same thing, but finding the zeros is a really good thing to know how to do. So we know how to solve this. You actually had an extra credit on this. How do you solve?
Divide by x.
Greatest common factor, good. And when I take out the x, what's left behind? Bueno, all right. And then we can do what? Factor, double bubble. So we have x times x is x squared, and what times what is positive 6? Good, negative 2 and negative 3. And then how do we actually solve for the values of x? Set them all equal to 0. So we get x is equal to 0. We get x is equal to positive 2. And we get x is equal to positive 3. And these are all the real zeros of x. Real as in they're not imaginary. And they're values of x for which our function is equal to 0. Now, the directions say find all the zeros. The nice thing is that that's also code for, hey, not only do we say find the zeros, but zeros just happens to be the same thing as what? Graphically. X-intercepts. That's exactly right. So not only do they say find the zeros, but zeros are exactly the same as x-intercepts on a graph. And so can you check this? Sure you can. You can graph your equation, your function, and look, where are the zeros? Where are the x-intercepts? 0, 2, 3. Not only can you just look, but you can use trace. And we have values for x. So you'll notice when I say x equals 0, y is 0. When x is 2, y is 0. And when x is 3, y is 0. Which is the reason they're called zeros. Okay? Because the y is 0. All right? So that's super handy to be able to, use your calculator to check. And on a test, if you were asked to find the zeros on a test, what could you do? Graph it. When in doubt, graph it out. Okay? So on a test, you might not even need to do any math because you could just simply graph the problem and see where the zeros happen to be. This is perfect justification on a test of what you did. Okay? I know exactly what you did on that test with your calculator. Draw a picture, label it, you're good to go. Okay? All right, example 2. Find all real values of x for which f of x is equal to g of x. That is the instruction. That is what they want us to do. What does that mean? Set them equal to each other. F of x needs to equal g of x. Well, I can replace f of x with the formula they gave us. Yeah, the square root of x plus 2. And I can replace g of x with the formula they gave us, 4 minus x. And then they want us to find x. Find the values for x. So how do we solve this equation? Isolate the radical. Thank you. Isolate the radical. So I'm going to go ahead and subtract 2. So I get the square root is equal to 2 minus x. And then how do we solve? Square both sides. So we are going to square both sides. And the square root of x quantity squared is x. What is this thing squared? Is it 4 minus x squared? No. No, it is not. Don't do that. 2 minus x times 2 minus x. You must FOIL that together. And what do you get when you FOIL that? 4 minus 4x plus x squared. And then now it's a quadratic function. How do we solve? So yeah, set it equal to 0. Good. Set it equal to 0. So we have 0 equals. I'm going to rearrange a little bit. X squared. I had to subtract an x, so that's going to be negative 5x and a positive 4. What? You good? You got it, right? Not good. Really upset. Okay, and then what do we do? Double bubble factor. Very good. What times what? Good. -4, -1, which means x equals 4 or x equals 1. Are they both the answer? No, they are not. How do I know that? You check it. Good. So here's the thing. When I see the original equation here, the degree is 1. The highest power of x is 1. The degree of the function tells me how many answers I should get. There should just be 1. Okay? It tells you at most 1. Yep. And so we need to check it. So again, when in doubt, the best way to check this is to use your calculator. So I'm showing you something incredibly useful right now. Anytime you're solving an equation, you can put the left side in y1 and the right side in y2. So that's what we're going to do. So take your calculator and we're going to type in the square root of x plus 2 in y1. And then 4 minus x in y2. 4 minus x. All right. And we're going to graph it. And if there were 2 solutions for x, we'd expect to see 2 intersection points. But how many intersection points do we have? 1 intersection point. So I'm going to make a little sketch. So there's my square root swoop function and my linear function. And there is 1 intersection point. So there's a couple of things I can do. First of all, I have some values for x. I think I'm going to try 1. So I'm going to use trace and hit 1. And I see that my y value is 3. And I look and see Tinkerbell is where I expect her to be at my intersection. But this was only for y1. We're only looking at the first equation. I can arrow down. And now I'm on the second equation. So I'm going to do that one more time and hit a 1. And I see that on my second equation, I'm at the exact same ordered pair, 1, 3. So that worked on both. You can check the table. So I'm going to go to the table. And those of you with Casios, you can do trace and you can do table as well. At 1, what do you notice about the y values? They're the same. That is what we're looking for, where we have balance, okay? When you check when x is 4, are they the same? Nope, we got a 4, we got a 0. So 4 is a false solution. That one didn't work. So x equals 1 is the only solution. I want to show you one more way, perhaps the best way. When in doubt, graph it out. On our calculators, you have a calculate menu. On the Casio, you have a G-solve menu. All right? For both of these, they're second functions. So on the Casio, you would do shift and then G-solve. So shift and then G-solve. On our TI, you do second calculate. And you take to the calculate menu. They're very similar. On the, so I do second G-solve. There we go. You can see intersection. On the Casio, you have root, max, min, y-intercept, intersection. All you have to do is press intersection, and it will give you the intersection of your 2 functions. It is incredible. On the TI, it's not quite so cool. We're going to go down to intersect. And what you're going to do is you're going to use the left and right arrow keys to put Tinkerbell on that intersection point where you think it is, and you have to hit enter 3 times. Enter, enter, enter. Casio, it's a 1-button push. On the TI, it's a 3-button push. Kind of annoying. So there it is. That's the intersection at 1, 3. Pretty cool. What's the solution for x? 1. X equals 1. That's the solution. Where our functions are equal to one another. Where the y values are equal to one another. Okay? This should be example 3, I think. Example 3. Find the difference quotient and simplify your answer. Welcome to the first 2 months of calculus. Find the difference quotient and simplify your answer. I'll tell you more about this in just a second. Okay, so first of all, here is our lovely function, our original function f of x. We've been doing function notation for a couple of days now, and it's important to know which function we are using. This is our f function. Next to it, this is the difference quotient that we are trying to simplify. Difference, meaning we are subtracting. Quotient, division. Okay? It's not rocket science how they choose the names. Difference inside quotient. Difference quotient. Okay? So we are dividing by h. Now, when I look at this, I see two parts. I see the first thing we have to figure out, and this is a direction. It says go to your f function, and what are we going to do? X is equal to h plus 4. We're substituting in h plus 4. So that's the light blue part. Then I have the big subtraction sign in red because it's subtraction. It always gets messed up. And then I have the second part, f of 4. What is f of 4 directing you to do? Yeah, plug in 4 for x. Where do we plug it in? Into the f function. All right, so otherwise, it's just algebra. Now, so don't get confused. We have a big quotient. It's dividing by h. This part right here, h is not 0. That's a little bit of extra information, and they're telling you we're not allowed to divide by 0. So they're just giving us the extra information that, yes, you're right, h is not going to be 0. Okay, that's really important. We don't really care about that too much. Okay, at this point, that's a calculus topic. Okay, so I have two parts. I have a light blue part, I have a subtraction sign, and then I have a pink portion. And I suggest you set it up just like this, okay? And we're going to fill it in. So the first thing I want to do, f of h plus 4 tells me to do what? Plug in h plus 4 everywhere we have an x. So I'm going to do 2 times what? H plus 4. And then I have a subtraction. And then I have h plus 4 being squared. It's kind of smushy right there. A little bit. H plus 4. That's not bad. And then we are going to subtract this whole pink part, whatever it is. We got to subtract the entire thing. That's the parentheses, okay? What is f of 4 telling us to do? Plug in a 4. That's going to be 2. Plug in a 4. Minus, plug in a 4 squared. That's the hard part. Everything else is algebra you've been doing for years. Pay attention. Watch your signs. FOIL. Carefully. So, I'm going to go ahead and distribute. My 2, what do I get when I distribute? 2h plus 8. Okay. I have a subtraction sign. You'll notice I'm subtracting something that I have to square. So I have to subtract the entire thing. Be careful. What is h plus 4 quantity squared? H squared plus 8h plus 16. I'm glad I didn't hear h squared plus 16. Most common mistake in pre-calc. Make sure that you FOIL that out to get there. Here, I have an 8. Can I distribute my negative too? Yeah, can I do that all in one? Are you okay with that? Okay, so that's going to give me a negative 8 And this would be 16 with a negative, so that's going to turn positive 16. Are you okay with that? Yeah? Okay. It's all divided by h. What else do I need to distribute now? My negative, one more there. Got one more negative to distribute. All right, so we have 2h plus 8 minus h squared minus 8h minus 16. Minus 8 plus 16, which you could combine, but I'm not going to because this is what's neat about the difference quotient. What happens? Positive 8, negative 8. What else? Negative 16, positive 16. It cleans up so magically, and that's what's kind of fun about it. Okay, I'm a math teacher. What do I know about fun? Okay, so agree. Okay. So left over we have a negative h squared and minus 6h, and it's being divided by h. Now tell me what this h is doing. Dividing each term, right? So I'm going to break it up. This is not the only way to do this. This is the way that I prefer to do it. Because we do this in calculus all the time. We got to break stuff up so it works out like we want it to. And you'll notice that our h's are going to reduce. And how do they reduce? Negative h minus 6. And that's it.
Wait, so what happened to the 2h?
To the 2h and negative 8h is negative 6h.
Wow.
All right. We are not solving. We don't have to isolate h. We're not solving. It's just simplifying. That's it. Okay? All right. How do you check it? That's a good question.
You just gotta be very careful.
Yeah, be very careful. I do think there's a way to check it, and it has to do with like picking a number for h, a kind of a crazy number, okay? And so if you pick a crazy number for h, and then 17 plus 4 is like 21 minus f of 4 over 17. So if you plug that in and figure out what is f of 21 minus f of 4 over 17, you get a number. If you plug that same 17 in here, you should get the same number. I think. I'm not exactly 100% sure. Okay? I'd have to look through my notes, old notes. All right, we got one more of these for extra practice. Yay! Woo! All right, we've got f of x equals x squared minus 4x plus 7. Now this actually is the definition of a derivative. That almost entirely the definition of a derivative. And again, what is this h cannot equal 0 here for? Yeah, we can't have a 0 in the denominator. So it's just extra information. It's weird that they, assume it everywhere else, but here they're being specific about it. So, all right, and again, we have two portions. We have the first part. We want to find f of x plus h, subtracting the second portion, the f of x. So I'm going to set it up just like this with the blue part minus the red portion all over h. Blue portion minus the pink portion. All right. So, f of x plus h, what does that tell you to do? Plug it in. Instead of x, what are we using? X plus h. Okay. So, go to your f function, and instead of x, we're plugging in x plus h. So that's going to be x plus h, quantity squared, minus 4 times x plus h, plus 7. Minus f of x. What do we have to do for f of x? No, what is f of x? It's that thing. It's the function itself. X is equal to x. No change. Same thing. X squared minus 4x plus 7. Okay. I need to FOIL my x plus h quantity squared. What do you get when you FOIL x plus h times x plus h? Almost. X squared plus 2hx or xh, however you want to say that. Plus h squared, good. I'm going to distribute. What do I get when I distribute the negative 4? Negative 4x minus 4h, good. Plus the 7. And then, what do I need to do with this negative? Distribute it, yeah. All right, so I'm going to distribute it. That's going to give me negative x squared plus 4x minus 7. This one's actually easier. All right, what cleans up? This is my favorite part. X squared and negative x squared. What else? Negative 4x and positive 4x. Positive 7 and negative 7. Lots of cleanup there. Super fun crossing stuff off a list. All right, what's left over?
H squared plus 2hx.
Good, minus 4h. All divided by h, which of course, that divide by h, what's he dividing? Each term above. So you could write it out if you want, or maybe you can just do it in your head because you're that good. That would be great. How does it clean up? What reduces? H plus 2x minus 4. All right, ladies and gentlemen. Did I catch that? That's it.